welcome to the Android Emulator Deep Dive. I'm Yahan, and this is Frank. We are software engineers from the Android Emulator team. So, back in the days in 2015, in the previous Android Dev Summit, we announced Android Emulator 2.0. So if you remember, here is what it looks like in 2015. And it's 2018 now, so things have progressed quite pretty fast, and we got a newer emulator with a newer look. So if you look at the details, there are a few differences you might have noticed. Firstly, there is a frameless skin support in the 2018 emulator, which doesn't have the window frame for you and gives you a better UI experience. And secondly, you might have noticed that in the expanded panel, there is a much longer feature list, which we have new features such as screen recording and virtual scene support, Snapshot, and Google Play Store. So I will go over all those features in this talk one by one. Yeah. From 2015 to 2018, we have developed quite a lot of stuff in the Android emulators, and we are mainly focusing on two areas. One is the performance improvement of the emulator. The other is new features. And we are focusing on improving your day-to-day developing experience as well as CI server testing use cases. So first thing first, let's get into performance. The first thing we want to focus on about performance is hypervisor support. So just a little bit background about hypervisors. That if you are running the Android emulator at the lowest level, you have your computer hardware. On top of it, you have your operating system. And the highest level, there is the emulated Android OS. Between the emulated Android OS and your real operating system, there lies the hypervisor, which translates the Android CPU commands into your OS CPU commands. So that's the part that we do the CPU acceleration. If you don't have a hypervisor, you can still run the emulator, but everything will go pretty slow, and the emulator will become super sluggish. So in 2015, here is the list of the hypervisors we support. On Linux, we have KVM. And on Windows and Mac, we support Hexam with Intel CPU. So unfortunately, back in the days, if you are using an AMD CPU on Windows machine, we have no support for this combination. So we got a lot of requests from AMD users to add support for them. So it's 2018 now, things progress pretty fast, and obviously we have new hypervisor supports. So firstly, we support a newer version of Hexam 7.3.2, which is stabler than the previous version, and it also gives you better performance. Then we added hypervisor framework support for Mac users, which in most situations is faster than the Hexam on Mac. And at last, we support hypervisor framework, also known as Hyper-V on Windows, which can emulate an AMD. So finally, the combination of AMD and Windows is supported. And yeah, this also gives Docker support. All right, so here is the hypervisor performance. The next thing we want to go into would be the ADB performance. So a little bit background, if you try to push an app from your computer onto your device when you are debugging or deploying, you are going to do this ADB push command, which copy and transfer the app from one end to the other. So here we are showing the chart for ADB push time on a physical device on two different Google apps, the Google Photo app and Google Center Checker app. and they are both on physical devices. And you can see what the first thing was that if you are using a USB cable and if you are pushing the Google Photo app, it takes you approximately 8 seconds. If you are using a USB cable, a USB 3 cable, things goes a lot faster and it takes you approximately 4 seconds. So you can observe similar phenomena when pushing different apps like the Google Center Checker. USB 3 cable is in general a lot faster than USB 2 cable. But those are for physical device. So how about the performance on the emulator? So here is a chart. If you do app push on emulator, the Google Photo apps takes approximately 0.5 seconds, which is a lot faster than USB 2 or USB 3. And these are the charts on an Android Oreo device. And it turns out that the OS version matters a lot as well when you are doing the app push. So we got a chart on the newer Android Pie device. And if you are working on a physical device, the ADB push is a lot faster on either USB 2 or 3. And emulator still gives you the best and very constant performance. So in short, if you are doing the app deployment onto the emulator, you are not going to have any worries about either USB cables or Android versions. We have you covered. You always get the best and consistent performance. All right, the next topic, we will go into quick boot and snapshots. So we will be showing demos. So with that, let's hand it to Frank.
Thank you, Yahan. So a top concern of Android Studio users is the time taken to deploy their app, whether it be to a physical device or emulator. And previously, people are used to this workflow where they're inside Studio and they want to deploy their app and they need to wait for the emulator to boot up again. So we tried to address this in 2017 and in 2018. The first way we try to address this is through snapshots. We call this quick boot. With quick boot, the device state is completely saved when you take a snapshot. And when you take a snapshot when you exit the emulator, and you resume from that snapshot when you start the emulator again. So in a sense, it's kind of like sleeping and resuming a real device. And we've also made improvements in recent emulator Canary versions to make it even closer to that. So the demo I'm going to show you here is I have two AVDs set up in the AVD manager. One of them is called API 28. We're going to be using quick boot with that. And the second one is called API 28 cold boot. And we're going to cold boot that. And so for the benefit of people who haven't seen this already, I'm going to cold boot one of these AVDs. You'll see that it starts out with a black screen. It takes a while to show the Google logo. But with quick boot, the emulator just pops up right here. You'll notice that Logcat has already started up. And we can interact with it immediately, just as the cold boot emulator has just started up. All right, so we're just going to get rid of the cold boot emulator for now and move on to the next part of the demo. So in addition to quick boot, in July of 2018, we've extended the snapshots feature to be more general. So with quick boot, you can only have one snapshot being saved and loaded at any one time. And that can be useful, but maybe sometimes you want to test different device configurations, different device states, and so forth. And before now, you didn't really have a good way to do that. But in the latest emulator stable version, 27.3.10, which was released July 2018, we're now giving you a generic snapshots UI. In this generic snapshots UI, you can save and load snapshots arbitrarily. So for example, I can immediately resume one of these snapshots to stopwatch running, and a stopwatch is running. I can also edit each one of these snapshots and add notes. And the description is saved and is also displayed over here. I can also take new snapshots with this Take Snapshot button. So these are some examples of what we have been doing with snapshots and trying to make your life easier when you're deploying apps and testing them. I would also like to, at this point, go over some improvements we made to the quick boot mechanism itself in recent emulator canaries. The version of the emulator running right now is 28.0.15. In the recent emulator canaries, we've tried to listen to your concerns about an extremely long saving time for the emulator when you're closing it. Now, if you want to save the emulator, actually, wait, let's just set up this stopwatch again. It's saved. Trust me, it is. Yes, it was saved. So we've employed new technologies like file backing of the guest RAM in order to speed this process up. In addition, we've also added some console commands that are useful for CI users when using snapshots. One very common workflow is to reset the device to a particular previous state, and then run your test, and then reset the device state again. To that end, we've added this command called, in the console, it's called avd snapshot remap 0. So assuming you're using the default settings, it's like you're auto-saving the current device state all the time. So right now we're on the second, we're at 40 seconds. And so if the first time you run this, it'll save it around then. But the next time you run it, it will very quickly rewind there. So this happens quite quickly because all the rest of the emulator UI and all that has already been set up. It's just a device state that's changing. So we can just keep doing this, like rewinding very quickly, and you can be in any state of the device and just keep going back to that one state very quickly with this command. Another feature that we've been working on in recent emulator canaries is launching multiple instances of the same AVD. So let me just set this up again. OK, 0 seconds. All right. So before, when you're using the emulator, if you want to test multiple different device states and launch them all at the same time in parallel, your options were pretty limited. You first had to create a whole bunch of AVDs that reflect the different device settings and launch them all in parallel, and you couldn't even start 2 instances of the same AVD because you got this error message saying that the AVD was already in use. Well, we have a new command for that now. It's called read-only. I will show you the command here. OK. Actually, it's missing, but I'll type it again. So it is called -read-only. And so when you run this command, the emulator will start, but discard all changes. I am starting it in the background just to make it easy to start many of them. So I've just started a second one. It's actually overlapped on the first. A third one, a fourth one. And so you have these AVDs that are all running independently, but they're off the same AVD name, because I just use API 28 for each of them. And notice here, I'm printing out the FPS and memory stats. And why are some of these only around 200 or 300 megabytes of resident memory? Well, that goes back to using a file mapping for the guest RAM. In this case, the parts of the guest memory that they share in common that they have not modified yet will be shared and will not occupy proportional set size or resident memory or what have you. So this is called copy and write. And we hope that this makes your experience developing apps and testing them more streamlined. Thank you. Now back to Yahan. Back to the slides.
Mm-hmm. Yeah, so I think it's kind of obvious to see, but here is a comparison of the boot time if you are using the quick boot feature versus if you are doing the cold boot. So and in the cold boot, it usually takes you more than 20 seconds to do the snapshot save on a MacBook Pro machine as we are demoing today. And on quick boot, it is usually about 1 second. So back to Frank for the next demo.
Mm-hmm. Yep, back to the demo. So the next part starts out with, we've also improved the GPU performance of the emulator in recent versions and in recent years. We worked a lot to bring OpenGL ES2 support very conformant and to support OpenGL ES3. To this end, we've created some benchmark demo apps that showcase what the emulator is capable of. So I'm just starting this test over here. And so you can run pretty real-time 3D applications like this that are competitive with real device performance. But before we go any further, I'd like to go back to Yahan and the slides to go over another interesting feature.
All right. So coming back to the snapshot support, if you remember in 2010, the emulator, like even before emulator 2.0, we have a quick boot feature and snapshot support. And back in the times, the emulator only supports snapshots for RAM, disk, and CPU. The big missing part here was GPU state snapshot. So this eventually forced our users to choose between a hardware GPU emulation and the quick boot feature. If you choose the hardware GPU emulation, you'll get a pretty nice runtime performance, but your boot time will suffer and you'll need a slow boot. If you choose the quick boot feature, your boot time will be fast, but you have no runtime hardware GPU support, which means the runtime performance will suffer. So this is in 2010, and people have always to choose one between the two. And it is 2018 now. We have better version of everything, including the hardware GPU snapshot support. This allows our users to choose both the quick boot feature as well as hardware GPU emulation simultaneously. So if you look at what was happening behind the scene for this hardware GPU snapshot support, here is the emulator GPU stack. At the highest level, you got the emulated Android OS, which issued GPU commands. At the lowest level, you got your hardware graphics card, which accepts and executes GPU commands. In between them, we have the emulator layer, which we call them translator. So the translator will translate GPU commands from the emulated Android into your hardware GPU. When we are doing the GPU snapshot support, we put all our snapshot logic into the translator layer, such that it will serialize its own state and dump them into your snapshot save file. So one big question here was the hardware state, which is eventually a black box to the emulator, and different vendors implement it differently. So to save and load hardware state, we use standard GL APIs to fetch all the hardware states from your hardware graphics card into the translator layer. Then the translator layer will serialize all of them and write them into your snapshot file. In this way, we can save and recover your whole emulated hardware GPU states. So that's, Frank, you want to talk about it?
All right, thank you, Yahan. Now, in this demo, I like to demonstrate that the GPU state is being snapshotted in its entirety. We didn't just do something special case for Android UI. it can resume 3D apps like this almost immediately with the snapshot load feature. All right. And you can, for those of you who don't know already, you can rotate the emulator orientation using these rotate buttons. So back to the slides. I would like to show a brief presentation. All right. So I know that many of you know this already, but for the benefit of people in the audience who don't know yet, we'd like to recap on some of the basic ways to use the command line to launch the emulator, which can include some useful options if you're running a CI server or otherwise power user. So the emulator resides in your Android SDK folder, Android SDK root/emulator. And once you're in that directory, you have to give the AVD name using the -avd command line option. Note that this name may differ from what's displayed in the AVD manager. So if you want to know what the exact sequence of characters that you need to input there, then you run emulator-list AVDs. Second, how do you control quick boot? Sometimes you don't want to use snapshots or you don't want to save your changes on exit. Well, got you covered. So the first one, no snapshot load, is to perform a cold boot without attempting to load the current state that is on the device. The second one, quick boot discard changes to snapshot, is good for some CI use cases and for people who just want the consistent startup experience and want to wipe it clean when they're done with it. In this, you enter no snapshot save on the command line, and all of the changes to the snapshot will be discarded when you exit the emulator. Finally, if snapshots are just not your thing, you can add no snapshot to the command line, and that will bring the emulator back to the way it was before. And to recap, in the demo I gave earlier, when I was launching multiple instances of the same AVD, well, that is the read-only option. That option will control whether you're allowed to run multiple instances of the same AVD or not. And when you're running in that mode, all of the changes to both the guest virtual disk and to the snapshot, whatever you do, it'll be discarded when you exit. To invoke this, you would run emulator-avd, the AVD name, followed by -read-only. And I put an ampersand at the end. You don't have to launch it in the background. It's just convenient for demo purposes here. All right. Now, I'd like to also talk about some of the command line options for some of the features that we have introduced recently to the emulator. In particular, screen record. Screen record is a feature where you can record the contents of the emulator to a video file and then play them back using your favorite app. This is great for CI users who want to be able to easily record what's going on when running tests on their app and to easily send reproductions of bugs to stakeholders. So the first set of commands concerns how to start and stop the screen recording. ADB emu screen record start, followed by the path to the file, will start the recording. And it is important that you provide the absolute path. Otherwise, you might not get it saved. It's a little confusing. Sorry, we're working on it. The second command, ADB emu screen record stop, stops the recording and is a signal to save the file. So after you're done with that, you can access the file. The second one concerns if you don't really want the full video recording part, you can instead just take a screenshot. In this use case, the console command is screen record screenshot, followed by path to the directory where you want the screenshots to be saved. Now let's go to the demo where I will demonstrate the screen recording commands. So we're in the emulator right now, and let's try to find a different app to record. Why don't we start up the camera? All right. So that's going on. And I'm going to run this. So ADB emu, AVD screen record, start, users, qualified, it's my username, documents, dev summit, demo.webm. So while it's recording, let's just move around in here a little bit to make something happen and stop the recording. OK, that's weird. It kind of. Oh, sorry. I accidentally typed AVD there. Yeah, so let's do another recording. All right, so the video is saved, and you can open it in your favorite web browser. OK, let's see. Yeah, there we go. So it's a WebM file. It will work in most major browsers. Second, there's also a UI for recording these screens. It is in the extended controls under the Screen Record tab. So in the Screen Record tab, it starts out with a single button, Start Recording. So once we're starting recording, we'll move around a little bit, maybe go to Recents, swipe away those apps, and stop. Now, once you're done recording, you don't have to save it to a file. You can preview it directly in the Extended Controls UI. So this is just a video of what we just did. Go to Recents, swipe away the apps, go back to the home screen. But you can still save it in wherever you want. So let's just save this as demo 2. And that similarly works in the browser. OK, so that's one of the features that we've added in 2017 and 2018 is screen recording to make your CI use cases better. Another feature that we've been doing a lot of work on, and is pretty exciting, is ARCore support. Now, ARCore support consists of a few main components. The first one, which you may have seen already, is the virtual scene camera. With the virtual scene camera, we render a virtual environment which is suitable to image recognition and model placement in AR apps. So I will demonstrate a few of them here. In the background, in Android Studio, I've opened the augmented image ARCore sample. This is available in Sceneform Android SDK from GitHub. And what ARCore provides, in it, it's not just for the emulator, but there's also integrations in Studio as well. So for example, there's this Sceneform plugin for Android Studio where we can view models that are meant for use in ARCore apps. In addition, we can change all the material properties we want directly in Studio. So this is the lower left frame, and I might just say lower the red tint a bit. OK, I guess that didn't really change the color very much, so I'm going to change blue to 0 as well. So once you save these files, the model should get reloaded, and you'll see that it's mostly pure green now. And we can, the workflow, we can just edit this model and deploy it to the device while we wait, I guess. Right. And so in this app, we are looking for images to recognize. Another feature that we've added to the emulator for ARCore support is the ability to load augmented images. This is in the Extended Controls panel under the Camera tab. Now, we can choose different posters to appear inside the virtual scene. And I've set this JPEG of the Earth to appear both on the table and the wall. So once you travel inside the scene with this, and turn face the wall. We're starting to detect the image, and it shows up there. So this shows that we can, if you're a developer of AR apps, you have this end-to-end workflow where you can start in Studio and do it all in the emulator with virtual scene camera. So that's pretty cool. Finally, another feature that I would like to mention, that I call out, unless if you haven't seen it before, is improved support for updating GMS Core and Google Play services. It is very important to app developers because they need to test how the app will actually run with different versions of GMS Core. If you are using a Google Play Store image, in the Extended Controls panel, there's a tab called Google Play, and inside it, there's this button that shows both your current GMS Core version and a button to update it. Once you press Update, you'll be taken to the Play Store and be given the option to update it. I happen to have updated already, and this is the latest version, so it does not give me a prompt to update here. But if a new version does come out, it would say Update. I would also like to talk about the integration of the Play Store and the emulator in general. So this can be useful for app developers who would like to test their app in more end-to-end scenarios. For example, if your app requires other apps to be installed in order to work, you can download them from the Play Store directly. Also, you can look at your app in the marketplace and see how users are reacting to it right there, and from different device sizes and form factors. And so that concludes the feature demos. So back to Yahan in the slides.
All right, so here is a summary of the features we talk about today. If you might have noticed, there are two channels of the emulator out there. So the first one is the stable channel, which is the one you normally get. The latest update was from July 2018. And the second channel is the Canary channel, which is less stable, but it has all the cutting-edge features we have in the emulator. And it is released weekly, so feel free to try it out. And in the stable channel, we have this list of features already released, including more hypervisor supports, quick boot feature, generic snapshot feature, the Play Stores, and screen recording, and the ARCore and virtual sensor supports. If you are trying out the Canary channel emulator, you have a few more steps, including the faster quick boot feature as we have shown in today's demo, as well as the multi-instance support. And for those of you who are curious about how to switch the channel, here is a quick instruction. In the Android Studio, you can turn on your preference page, and in the update, you have your channel switch right there. After that, you go to the emulator download page, and you'll see the newer version available for download. So I believe that concludes our talk. So we'll be QAing in the laundry. So thanks for attending.
Thank you.